trigonometric identities. In this lesson, we are going to focus on simplify by rewriting trigonometric expressions. Basically, this part has 4 different types of questions. Simplify by rewriting only sine and cosine, simplify by factoring, simplify by combining fractions, and rewrite to eliminate fractions. But before starting, you must know about reciprocal and quotient identities, Pythagorean identities, co-function identities, and odd-even identities. Let's remember Pythagorean identities. Let's write over here. We know that sine squared plus cosine squared makes 1, and tangent square plus 1 is secant squared. Last one is cotangent squared plus 1 is cosecant squared x. So, about each part, I'm going to solve 2 examples. If you are ready, let's start. First one, simplify by rewriting only sine and cosine. Example 1. Let's simplify cosecant x times secant x minus tangent x. Our point here is to write everything in terms of sine and cosine. So first one can be written as 1 over sine x, and second can be written as 1 over cosine x minus sine over cosine x. As you can see here, if you have 2 fractions, we must equalize their denominators, which means I have to multiply denominator and numerator by sine x. So this makes 1 minus sine squared x over sine times cosine. 1 minus sine squared is cosine squared, and down we have sine x times cosine x. So let's simplify cosine and cosine. So up cosine x left. Final answer is cosine over sine, but we can simplify this more, which can be written as cotangent x. Our second example is tangent plus sine times secant x over cosecant x times tangent x. Rule does not change. Our point here is to write all of them in terms of sine and cosine. So let's start from the numerator. Tangent can be written as sine over cosine. Sine times 1 over cosine. Over cosecant is 1 over sine times tangent is sine over cosine. We can cancel out sine x. So here, as you can see, denominators are equal. I can add numerators. Sine x plus sine x, it makes 2 sine x over cosine x times 1 over cosine x, it goes up as cosine x over 1 if you flip the fraction. So cosine cancelled out. What's left here is 2 sine x, and this is the final answer. So, about the second part, which is simplify by factoring. Let's take the first example here. Cotangent x minus cosecant squared x times cotangent x. And the other example is negative cosecant pi over 2 minus x minus tangent squared x times secant x. So here, as you can see, cotangent is common. Let's take out of the bracket and write what is left. 1 minus cosecant squared. So what is 1 minus cosecant squared? Let's remember, cotangent squared plus 1 equals cosecant squared x. Here, this is in form of 1 minus cosecant squared, which means if I shift cosecant squared to left side and cotangent to right side, I will get 1 minus cosecant squared equals negative cotangent squared. So instead of this part, I can write negative cotangent squared. Cotangent times negative cotangent squared makes negative cotangent to the power 3. This is the final answer and simplest form. Let's check next example. So first of all, we know that cosecant pi over 2 minus x is secant x minus tangent square times secant x. So let's take negative secant x out of the bracket. So what's left here is 1 plus tangent square x. And we know that tangent squared plus 1 is secant squared. So we got negative secant x times secant squared x, and which makes negative secant cubed x. This is the simplest form. So, the part 3. Let's check example 1. Simplify by combining fractions. Our first example is cosine x over secant x plus 1 plus cosine over secant x minus 1. If you see two different fractions, try to equalize their denominators, which means I have to multiply this by secant minus 1 and this by secant plus 1, numerator and denominator. So this makes cosine times secant x minus 1 plus cosine times secant x plus 1 over secant x plus 1 times secant x minus 1. Let's distribute. It's gonna be cosine times secant minus cosine plus cosine times secant plus cosine over secant squared minus 1. What is secant squared minus 1? Let's remember, we said tangent squared plus 1 equals secant squared. So if you shift 1 to the right side, it will be secant squared minus 1 equals tangent squared. So instead of this, we can write tangent squared x. Let's check numerator. Negative and positive cosine x cancel each other. So what is left here is 2 cosine x and secant x over tangent squared x. So let's check this one. Instead of secant, I can write 1 over cosine x. So cosine and cosine cancel each other. What's left up is only 2, and down tangent squared. And this can be written as 2 times 1 over tangent squared. And as you know, 1 over tangent squared is cotangent squared. So let's check another example. Example number 2. 1 minus cosine x over tangent x plus sine x over 1 plus cosine x. So first of all, let's convert tangent to sine over cosine. So this can be written as 1 minus cosine x. If you flip this fraction, it will be cosine over sine x plus sine x over 1 plus cosine x. So right now, we can equalize denominators, which means I'm going to multiply this by 1 plus cosine x, this by sine x. So 1 plus cosine times 1 minus cosine is 1 squared minus cosine squared times cosine plus sine squared over 1 plus cosine times sine. Let's remember, 1 minus cosine squared is sine squared x. As you can see, sine squared is common. Let's take out of the bracket. What is left here is cosine x plus 1 over 1 plus cosine x sine x. So we can cancel cosine x plus 1. Here, let's cancel sine x and sine x. So only 1 sine x left. So final answer is sine x. So let's check the last part. Part number 4. Rewrite to eliminate fractions. Our first example is sine x over cosecant x minus cotangent x. In this kind of questions, if you have only one fraction, we multiply denominator and numerator by conjugate, which is cosecant x plus cotangent x. So up you have sine x cosecant x plus cotangent x over cosecant squared minus cotangent squared. So let's check this one. As we know, cotangent squared plus 1 equals cosecant squared. So from here, if you shift cotangent square to right side, you'll get 1 equals cosecant squared minus cotangent squared. So instead of this part, I can write 1. What is left here is sine x times cosecant x plus cotangent x. So let's distribute. You will get sine x times cosecant x plus sine x times cotangent x. So let's change cosecant and cotangent to sine and cosine form. So this can be written sine x times 1 over sine x plus sine x times cosine over sine x. So as you can see, you can cancel out sine x. So what is left here is 1 plus cosine x. And this is the final answer and simplest form. Let's check the last example. Part 4 and last example. Let's look at this example. Sine x times tangent x over cosine x plus 1. As we mentioned before, in this kind of questions, we multiply denominator and numerator by conjugate. So let's rewrite sine times tangent times cosine minus 1 over cosine squared minus 1. As you know, cosine squared minus 1 is, let's look at here, sine squared plus cosine squared equals 1. But this is cosine squared minus 1. So which means cosine squared minus 1 is sine squared, negative sine squared. So instead of this, I can write here negative sine squared x. I can cancel sine and sine. So down, negative sine x left. Let's rewrite everything. Up I have tangent x. In the bracket you have cosine x minus 1. Let's put this minus up over here. And down you have sine x, which can be written as 1 over sine x. So let's continue. As you know, tangent can be written as sine over cosine. Here you have cosine minus 1, and here you have 1 over sine x. So I can simplify sine and sine. So what's left here is negative 1 over cosine x times cosine x minus 1. Of course, we are going to distribute, which makes negative 1 over cosine x times cosine x and plus 1 over cosine x. So cosine cancelled out. This can be written as negative 1 plus 1 over cosine is secant x. This was the last question. I hope you understood